Hello everyone, so today we will study about Cauchy's integral test, and with the help of this test we will find whether the given series is convergent or divergent. Okay, so let us see the conditions of Cauchy's integral test. First of all, the function f of x should be a non-negative monotonic decreasing integrable function. Okay, the function f of x should be non-negative, means it should be positive મોનોટોનિક ડિક્રીઝિંગ ફંક્શન. જે સિરીઝ આપેલી હોય એ ડિક્રીઝિંગ ફોર્મમાં હોવી જોઈએ અને એની બધી ટર્મ્સ છે એ કેવી હોવી જોઈએ? નોન નેગેટિવ. ઇટ મીન્સ પોઝિટિવ ટર્મ્સ હોવી જોઈએ. ઓકે, that we will see in the example, so it will be more clear to you. And if this condition is satisfied, then you have to take integral 1 to n f of x dx. Okay, and you have to find the answer, and if that answer is finite, then that function will be convergent, otherwise it will be divergent. Okay, and here you have to put limit n tends to infinity. Okay, after putting limit n tends to infinity, you will get the final answer, and if that answer is finite, then the given function will be convergent, otherwise it will be divergent. And the value of the sum of the series lies between, and if you want to find the sum of the series, then it will be I equal to limit n tends to infinity in and I plus f1. f1 means in the function you have to put the value n equal to 1. Okay, it will be more clear to you when we will solve the examples. So, example 1. Summation n equal to 1 to infinity 1 by n into n plus 1 is given. Here it will be asked that solve it by using Cauchy's integral test, and if it is not asked, then also you can check. Because by putting the value, if we will put the value n equal to 1, then here we will get 1 by 2. Then if we will put 2, then we will get 1 by 6. Means its value will keep on decreasing. For example, if I put f1, then it will be 1 into 2. If I calculate f2, then it will be 1 by 2 or 1 by 6, and so on. So its value will keep on decreasing, and all the values are positive. Okay, જ્યારે આપણે વેલ્યુઝ પુટ કરશું 1 2 3, then આ વેલ્યુઝ છે બધી ડિક્રીઝ થતી જશે. So it is a non-negative, and all the values will be positive. So it is a non-negative monotonic decreasing sequence, and whenever it is a non-negative monotonic decreasing sequence, you have to apply Cauchy's integral test. Okay, so here by putting the value we can get the idea that here we can use Cauchy's integral test, because the given series is monotonic decreasing sequence and it is positive. Okay, so it satisfies the first condition. So we have to write our un will be 1 by n into n plus 1. But we have to put the limit in the function f of x. So what will be our function f of x? F of x will be, in place of n you have to substitute x. So you will get the function f of x, x into x plus 1. Okay. Now we will put in the given condition 1 to n f of x dx. So that is equal to 1 to n f of x dx. Okay. Now here we can apply the AB rule, that is here we can use like this: a by x plus b by x plus 1. And you all know this, how to solve this. By taking the LCM, you will get the value of A and B. You will get A equal to 1 and B equal to -1. You can check. Okay? You all know this, so no need to solve it. So I am not solving it here, but you have to solve it and find the value of A and B. So whenever you will get value of A and B, we can rewrite this equation as 1 to n. We have to put this limits of A and B here. So here we will get 1 by x minus 1 by x plus 1 dx. Okay. And now integrating it, we will get the answer. Integration of 1 by x will be log x, and integration of 1 by x plus 1 will be, log x plus 1. Okay. And now if we put this limit, say here, then we will get, but we can rewrite this equation as log a minus log b હોય તો એને આપણે આવી રીતના લખી શકીએ log a by b. So here we can write log x by x plus 1, and then we will put this limits. So it will be more easier. So we can write log n by n plus 1 minus log 1 by 2. Okay, log 1 and 1 plus 1 2. So log 1 by 2. Okay. Now what was the other condition? The condition was, this is our ion. And in ion I told you that we have to put the limit n tends to infinity in the ion. After getting this ion, you have to put this limit n tends to infinity in this given ion. So we will get, if we put the limit here, but before putting the limit, if I take n common from the denominator part, then I can write like this, 1 plus 1 by n minus log 1 by 2. This n and this n will get cancelled. So we will get log 1 by 1 plus 1 by n minus log 1 by 2. Now finally if we put the limit, then we will get, now if we put limit n tends to infinity in the ion, then here if we put infinity, then it will be 0. So we will get log 1 minus log 1 by 2. But you all know the value of log 1 is 0, and value of log 1 by 2 you can calculate in the calculator. It is minus 0.301. Again this minus will be plus. So answer will be 0.301. Okay. And as we got the finite value, we can say that according to Cauchy's integral test, we can say that as ion is finite, according to Cauchy's integral test, the answer is convergent. Okay. Now here you can also find the sum of the series. It is not compulsory to find the sum of the series in any example, but if you find, then it is good. Okay. Then how we can find the sum of the series? We have already seen here that the sum of the series lies between I equal to, here let us find by using this formula. So sum of the series lies between, what is the formula? I equal to limit n tends to infinity of ion and I plus f1. Okay. So here limit n tends to infinity ion means whatever the answer we got, that is 0.301, that was our ion. So here directly we have to put its answer. And What is I plus F1? Again, our I is again this 0.301. And what is F1? Then in the f of x, in this f of x, we have to put F1. That is x equal to 1. Then we will get F1. So 1 by 1 into 1 plus 1. So that is 1 by 2. So our f of 1 is 1 by 2. So here we have to put 1 by 2. And 0.301 plus 0.5, that is equal to 0.801. So we can write that the sum of the series lies between these two values, that is 0.301 and 0.801. 0.301 and 0.801. Okay. In all the examples, they are not calculating the sum of the series. It is not necessary to find the sum of the series, but it is better if you find. Okay. And sometimes in the exam, if it is asked to find the sum of the series in the MCQ or in the 1 mark question, then you can easily find it by using this formula. Okay. Sometimes they can also ask in the example that check whether the given series is convergent or divergent, and also find the sum of the series. Then during that time you can find the sum of the series. So example 2. Test the convergence of summation n equal to 1 to infinity 2 tan inverse n by 1 plus n square is given. Now you can put value and check here that again this is a decreasing series. If we put n equal to 1, then you can check, you will get 0.78. If you put f2, then you will get 0.44, and if you put n equal to 3, then you will get 0.25. So again it is a decreasing, non-negative, monotonic function. So again we can apply here Cauchy's integral test. So now this is our un, 2 tan inverse n by 1 plus n square. But we have to find f of x. So f of x is equal to 2 tan inverse x by 1 plus x square. Now we will apply the rule of Cauchy's integral test, that is integral f of x dx. Now here you can write 1 to n, or you can directly write 1 to infinity. Okay, so I am writing directly 1 to infinity because at last we are putting limit n tends to infinity. So our function will be 2 tan inverse x by 1 plus x square. Now here we will take tan inverse x is equal to t. Okay. So we will get 1 by 1 plus x square equal to dt if we differentiate both the sides. So now let us put these values in the given equation. So we will get, also the limits will change, that is limits will change to pi by 2 and pi by 4, because whenever we will put here x equal to 1, then we will get pi by 2, and whenever we will put x equal to infinity, then we will get pi by 4. Okay, so here we have dx by 1 plus x square equal to dt. So here in place of this term we can write directly dt. So we got pi by 2 to pi by 4. If we write 2 outside, then it is t dt, and now integrating we will get integration of t is t square by 2, and the limit will be pi by 2 to pi by 4. And now if we put the limit here, then this 2 and this 2 will get cancelled, and putting the limit we will get pi square by 4 minus pi square by 16, and that is equal to 3 pi square by 16. So we got finite value. So according to Cauchy's integral test, answer is convergent. And now here also you can find the sum of the series, that is equal to in and in plus f1. So what was our in? We got 3 pi square by 16 and 3 pi square by 16 plus what was our function f of 1? 0.78. So we can directly write here 0.78. Okay. But in all the examples they are not finding sum of the series, but if in the question it is asked to find the sum of the series, then you have to find the sum of the series. Okay. 3. Summation n equal to 3 to infinity 1 by n log n under root log square n minus 1 is given. Now what is given here? That n equal to 3 to infinity. Then here we will get summation 1 થી infinity આપેલું હોય તો એ આપણે શું લખતા હતા? integral 1 to n. If summation n equal to 3 to infinity is given, then here we can write 3 to n. If 4 is given, then it will be 4 to n. Means whatever will be given here, that will be our limit of integration. Okay, so here our integral will be 3 to n. Okay. So now again you can check, it is a non-negative monotonic decreasing series. So again we can use Cauchy's integral test. But in Cauchy's integral examples, most of the time they are asking that solve it by using Cauchy's integral test. But if it is not told, then you can check it by putting the values, and if it is a non-negative monotonic decreasing series, then you have to use this test. Okay. So again our un is 1 by n log n into log square n minus 1. So our f of x will be 1 by x log x into log square x minus 1. Now here we can assume that let log x be y, so that we can easily solve the example. Okay, so take log x equal to y, and so we can write x equal to e raised to y, and differentiating both sides we get dx equal to e raised to y dy. And also the limits will change. Okay. In the integral in, our limits will also change. That is, first it was 3 to n. I am writing as it is. Then I will put all these values. Okay. Now if I put all these values, then limits will also change. That is, whenever x is 3, and if we convert it into the y form, then here we will get limit log 3 to log n, log 3 to log n. Okay, so let us put all these values in this equation. So we will get log 3 to log n, and in place of here there is dx. Okay. So here in place of dx I can put e raised to y dy. So in the numerator part we can write e raised to y dy by. In place of x we can write e raised to y, and in place of log x here we can write y. So e raised to y into y. Again in place of log square x we can write y square minus 1. So this is the final the equation which we got after putting all the values. Now this e raised to y and this e raised to y will get cancelled. So we will get like this, log 3 to log n dy by y square minus 1. But you all know that this is the formula of 1 by y into y square minus 1 is the formula of sec inverse y. Okay, mod y. So in place of this term we have to write sec inverse mod y. So this integration is equal to sec inverse mod y, and we have to put the limits. And now putting this limits here, we can write sec inverse log n minus sec inverse log 3. Okay, and again putting the limit in the in, we will get pi by 2 minus sec inverse log 3. If you put n equal to infinity, you will get pi by 2 minus sec inverse log 3. And again you can, no need to calculate it, you can say that the answer will be finite. And answer છે કાંઈ finite જ આવવાનો છે, infinite નહીં થાય. Pi by 2 minus sec inverse log 3 will be always finite. So if the answer will be finite, we can say that the series is convergent. Okay. Example 4. Use Cauchy's integral test to check whether the given series is convergent or divergent. 1 by 2 into 3 plus 1 by 3 into 4 plus 1 by 4 into 5 up to infinity is given. Okay. We can solve this by using other tests very easily, but here it is asked to solve with the Cauchy's integral test. So here we have to use Cauchy's integral test. Okay. So again our un will be 1 by, here we have 2, 3, 4, means it is the form of n plus 1. Okay, because whenever we will put n equal to 1, we will get 2. N equal to 2, then we will get 3. So it is the form n plus 1. And here we have 3, 4, 5. That is n plus 2. Okay, so it is the form of 1 by n plus 1 into n plus 2. Now as it is a Cauchy's integral test, we have to find f of x. So f of x will be 1 by x plus 1 into x plus 2. Okay, and as again if you put the values, and you can check here also that it is a non-negative monotonic decreasing series, decreasing function or series. So now if we put integral in equal to 1 to n 1 by x plus 1 into x plus 2. Again you all know how to solve this form, that is by using a by x plus 1 plus b by x plus 2 form. And again if you will solve it, you will get value of a1 and b minus 1, and you have to substitute these values here. So we can rewrite this equation as 1 by x plus 1 minus 1 by x plus 2. So now integrating it, we can write 1 by x plus 1 is equal to log x plus 1. And 1 by x plus 2 is equal to log x plus 2. And now putting the limits in this terms, we get log n plus 1 minus log n plus 2. Putting the term 1, we get log 1 plus 1, that is log 2 minus log 3. Okay, but again it is a form of log a minus log b, so we can write log a by b. So we can write log a by b, but here also if we take the terms common, if I write like this, log 3 plus log 3 minus log 2. Okay, Then we can write, again here we can apply. Here I have done nothing, but I have took the minus sign common. So it will be plus log 3 minus log 2. So we can again apply here also. We can apply a by b rule. So that will be equal to log 3 by 2. Okay. So now if I put the limit in this terms, that is limit n tends to infinity, then I will get, again if I take n common from numerator and denominator part, then it will be 1 plus 1 by n, and here also log 1 plus 2 by n plus log 3 by 2 as it is. And now if I put the limit, then here it will be 1. Okay, log 1. So value of log 1 will be again 0, and we all know that value of log 3 by 2 will be 0 plus log 3 by 2 will be some finite value. And as we got the finite value, the answer is convergent. Okay. In order to get this positive sign, here I have multiplied this minus sign inside. So here no need to be confused here, but you just have to bring positive sign, so that the answer will be in the positive form. Okay. So I just multiplied this negative sign inside, so it will be log 3 minus log 2, and here we will get positive sign. So answer will be log 3 by 2, and as again if it is a finite term, so according to Cauchy's integral test, the answer will be convergent. We will continue with the examples of Cauchy's integral test in the next lecture. So do practice this type of examples at your home. Thank you everyone. I hope you all liked my video lecture. Thank you. Example 5. Summation n equal to 1 to infinity 1 by n into 1 plus log square n is given. So now again here we can apply Cauchy's integral test, because you can put value and check. Again it is a non-negative monotonic decreasing function. Okay. So our un will be 1 by n into 1 plus log square n. But according to Cauchy's integral test, we have to find f of x. So f of x will be 1 by x into 1 plus log square x. Okay. Now here we can assume log x equal to t, and differentiating both the sides, we will get 1 by x dx equal to dt. So our in will be, we can directly put the limit, that is 1 to infinity, or you can also put 1 to n, and at last you can put the limit. So here we can put 1 to infinity, 1 by x into 1 plus log square x. And again here it is better to put 1 to infinity, because it will be easier to change the limit. So again the limits will change. Whenever we will put log x equal to t, limits will change to 0 to infinity. So here we can write 0 to infinity, and again 1 by x dx is equal to dt. So and log square x is t, so we can write 1 plus t square into dt. Okay. Now 1 by 1 plus t square is equal to tan inverse t. So here in place of this we can write 0 to infinity, integration of 1 by 1 plus t square is equal to tan inverse t. So here we directly have to put the limit in this function. So we will get tan inverse infinity minus tan inverse 0. Okay, and value of tan inverse infinity is pi by 2, and tan inverse 0 is 0. So answer will be pi by 2. Again the answer obtained is finite. So according to Cauchy's integral test, answer will be convergent. Okay. Example 6. Test the convergence for summation n equal to 1 to infinity n e raised to minus n square is given. So again it is non-negative decreasing monotonic function. So we can again apply your Cauchy's integral test. So un will be n e raised to minus n square. But we have to find f of x. So f of x will be x e raised to minus x square. Now again we have to find integral in, that is equal to 1 to infinity x e raised to minus x square dx. Now here we can assume x square equal to t. We can put x square equal to t, and differentiating both the sides we will get 2x dx equal to dt. So value of x dx will be dt by 2. So here in place of x dx we can write dt by 2. So putting the values, and also limit will remain 1 to infinity. So here we can write e raised to, value of x square is t. So e raised to minus t into dt by 2. Okay. And writing 1 by 2 outside, we can write 1 to infinity e raised to minus t dt. But value of e raised to minus t is equal to first we have to integrate it, e raised to minus t dt. So integrating the e raised to minus t, we will get e raised to minus t by minus 1. And now and limits will be 1 to infinity. But e raised to value of t is x square. So we have to write e raised to minus x square by minus 1 to infinity. So we can rewrite this equation as minus e raised to minus x square by 2. Now if we substitute limit here, then we will get e raised to minus 1 by 2. Okay. And again the value of e is 2.714, but you can check it. The answer will be finite. And as the answer is finite, again the given series is convergent according to Cauchy's integral test. Okay. So in this way you have to solve the examples of Cauchy's integral test. Now these are some examples for practicing. 4 sums are there and also answers are given in the bracket. Do practice these examples. Thank you everyone. I hope you all liked my video lecture. Thank you.